Good morning, everybody. Welcome to a cold, snowy Tuesday morning at Chem 1211 with your host, me, Dr. White. Now, I have a personal request for all of you, and that is who's ever dreaming of a white Christmas, stop! It's too early. Got to wait at least till after Thanksgiving. Actually, wait until the middle of December. I don't know about where you are, but my lawn is covered with snow, a lot of it. So are all the branches and trees and bushes around my house. It's quite pretty, but stop dreaming of a white Christmas. It's too early. All right, let's get going. Uh, First of all, important announcement. As I promised, I posted calculations for the airbag lab. I've also postponed the due date. It's not due today. It's due a week from today, which is, looking at a calendar I have up here, the 22nd. Got this years ago, years and years ago. And it works nicely. I don't even know if the company's still in business. It's a 200-year calculator. So I got a long time to keep on using it, because I think I got it in 95. So I got 200 years worth on that. But anyways, the lab that was due today is due next Tuesday. If you've already handed in a lab, you can hand in a second lab, and that's the one I'll grade if you're concerned that I do the calculations. Now, let me open up Blackboard. I put out an announcement, but let's go to assignments. Let me make sure you can see it. That would help. All right. I assume everybody can see the assignment area. I have today's lab up there, but you'll see here is the airbag lab. And notice the very last two files. I have two files for calculations. One's a PDF, one's a MS Word file. All right, does everybody see the calculations for airbag lab from me on your screen? Thumbs up, people, help me out. Uh-oh. Now do you see it on your screen? All right, let's do this first of all. Let's try this. Now, can you see it on your screen? Send me a chat, yes or no. Thank you, Gianna. All right. Well, I got scared for a second. Ah, but anyways, here I have the different steps. For step one, you'll need to calculate the moles and to fill an airbag. And you do that from PV equal nRT, and I've done that for you. Now, remember, for PV equal nRT, the pressure, volume, and temperature have to be in the right units. Now, the barometric pressure you can get from any website like the Weather Underground, and it'll be in inches of mercury. And you take P barometric pressure, what's in inches of mercury, and you do these two multiplication, and you'll get it in atmospheres. All right, next, Kelvin, you're going to measure the temperature in your room where you're doing the experiment, and you'll get degrees C. And here's the formula to convert it. And you should do that. Now, the plastic bags in your kit have a volume of 1.20 liters. Ours is still 0.0821. And you put in from step 2 that pressure in atmospheres. The volume is step 4, the temperature is step 3, and R is given you 5. And you'll get a number, moles of CO2. You'll use this number with the following reaction. And to get the grams of sodium bicarbonate, baking powder, you'll use this equation, N moles, and the N comes from step 6, and you multiply by 84.0 divided by 1, and you'll get grams of sodium bicarbonate. To get the milliliters of the vinegar, because you're given the molarity of the vinegar, you have N moles of, this is acetic acid. Here's the molarity of acetic acid in vinegar, and you use this equation, and you'll get the milliliters of vinegar. Now, for the other parts where they ask you to add a little more and more, you add it to the amounts you calculate in steps 8 and 9. And at the very end, they ask you, well, for a car, how much sodium bicarbonate and vinegar do you need to fill a car airbag? Well, car airbag, consider for PV equal nRT to get N, you'll use temperature 25 degrees C. They give you the volume of the airbag at 80.0 liters. And let's assume to make your life a little easier, that it's 1.00 atmosphere for the pressure. And use the values for 9 and 10 with these numbers here to calculate the numbers in steps 9 and 10 for the car airbag. And that's how you do that lab. Any questions? Well, in that case, let's get back to something important now for quiz 5, and also it will help you on today's lab. Interesting, before it didn't pop up, now it did. So I know you're watching this. All right, we were talking about Le Chatelier's principle. Remember, I'm using my North Side Chicago French accent. And when a chemical system at equilibrium is disturbed, the system shifts in the direction that minimizes disturbance. And yesterday, we looked at concentration. And if we go back to our here's our equilibrium, A plus B, and the double-headed arrows tells you it's an equilibrium and makes C plus D. And C plus D react to make A plus B. They go back and forth. Remember, the chemical rate of reaction in each direction for a chemical equilibrium is the same. Now, at equilibrium, There's a certain amount of A, certain amount of B, certain amount of C, certain amount of D. And you'll be doing some of this later today or whenever you do today's lab. Now, let's look at the following question. With that equilibrium, A plus B equilibrium of C plus D, what happens to the concentration of A and C when you have the bracket formula, close bracket, that's concentration, moles per liter, how much you have. And the question is, what happens to the concentration of A and C in this equilibrium if you add more B? Now, at equilibrium, there was a certain amount of B. Now we've added more B and it's under stress. Oh, I've got too much B. Oh, what do I do? Well, you got to get rid of some B. The only way you can get rid of the excess B is for B to react with A. That makes C and D. That's called shifting the direction of the equilibrium, in this case, to the right. So if A and B react, A is reacting. It's consumed. When something is consumed, you have less. Remember, I talked about if you had one of those smile cookies, I got to buy one of those. I haven't had them in ages. And you eat half of it. Do you have the same amount of cookie in your hand, more or less? Less, because you consume some of it. So therefore, since A reacts, the amount will decrease, goes down. You can use an arrow, or you can write it. And you can actually say is less too. Well, to get rid of the excess B, A and B reacted to make more C and D. Well, if I make more of something, guess what? The amount I have will increase. And you can write as an arrow up, or you could also write goes up, or does would be. And that's how you do it. So, your turn. What would happen to the concentration of A and B, A and C if you remove some B? Take it out. In other words, the concentration will be lower. So what happens to the concentration of A and C? Your turn. And once again, for those of you who are dreaming of a white Christmas, stop. Wait until December, please, or at least wait until after Thanksgiving. When I was young, you didn't see any Christmas ads or any sales or anything until after Thanksgiving. Boy, that has changed. I think they started some sales last summer. And when you're done, give me a thumbs up. I'll give you a hint. At equilibrium, there was a certain amount of B. Now we've taken some out, and the reaction is under stress and says, oh no, I don't have enough B. Hint. Now, when you take the quiz, you don't have to do this or go like this, but that's the thought process without the special effects. And when you're done, don't forget, give me a thumbs up. Thank you, Anna. Ooh, we've got G squared today. Thank you, Gianna W. Thank you, Jasmine. And thank you, Gianna J. All right, let's look at this. What happens to the amount of A and C if you remove some B? Well, at equilibrium, there was a certain amount of B. Now there's less. And let me clean this up a little. Since there's less B, says, oh, woe is me, I need more B. Well, how can it make more B? C and D react to make more A and B, or B and A. Well, if C and D react, when something reacts, it's consumed. Just like the cookie, when you eat half of it, consume it, there's going to be less. So the concentration of C will decrease. Same thing with D. And you can put an arrow down, or any one of these would be correct. Now, to replace the B that was removed, you make more B. Well, when you make more B, you're going to make more A. And when you make more of something, guess what? The amount you have will increase. Arrow up, or you could have also written goes up. And that's how you do that. Now, a very important aspect of the Chatelier's principle deals with exothermic reactions and endothermic reactions. Exothermic gives off heat. Endothermic, you have to add heat. Ooh, see board, I've got to get to work. Now, the classic way of determining this is, first of all, let's consider an exothermic reaction. Oh, look, new letters. All right, because it's exothermic, you also make heat. This tells you that when it's on the right side, heat is given off, which is what an exothermic reaction is. So before we go to this, let's talk about something, and that is, how do you add or remove heat from a reaction? if you make an ice bath, which is a mixture of ice and water, it's cold. And why it's cold is because this removes heat. Another way of saying that is you lower the reaction temperature. And the key thing is it removes heat. Oh, in light of today's snowstorm, I'm going to be subtle. You should know that an ice bath removes heat. Now, the opposite of that is a beaker of boiling water or just hot water. Whoops, I almost wrote H2O, which would have been all right, but I already wrote water there. And this adds heat. And you should know this also. Boiling water or hot water, and what it does is increases the reaction temperature. Oh, I forgot an E up here. So, ice bath removes heat, boiling water or hot water adds heat. Now, let's go back to our exothermic reaction. And question would be, and for today's lab, you'll be doing stuff like this. It's going to be neat. But anyways, but I'm a chemist. I like this stuff. All right, 4 points each. What happens to the concentration of E and G if I put the reaction in an ice bath? Well, what does that mean? Oh, look, someone was nice enough to write on the screen, ice bath removes heat. Now, at equilibrium, there was a certain amount of E, certain amount of F, certain amount of G, certain amount of H, and a certain amount of heat. By putting it in the ice bath, you've removed the heat. It's under stress. Oh no, I don't have enough heat. It needs to make more heat. How can it make more heat? The equilibrium is shifted this way. E and F react to make more G, H, and heat. So if I shift the equilibrium this way to make more heat, I'm going to make more G and H. Well, if I'm going to make more something G, what happens to the amount, the concentration? It will increase. Goes up, you can write an arrow. And again, it's increasing because you have to make more heat to replace what was removed by the ice bath. And when you make more heat, you're going to make more G and H. Now, how do you do that? You react E and F. When anything is reacted, it's consumed. And like the cookie, I'm getting hungry. I want one of those, but I'm not going to get one. I need one like I need a hole in my head. But anyways, when it's consumed, you have less. So the amount will decrease, go down. And that's how you use Le Chatelier's principle for one type of exothermic reaction change. Let's look at the other one. What happens to the concentration of E and G if I put the reaction in hot water? And if we go up here, oh, someone was nice enough to write on the whiteboard here, boiling water or hot water adds heat. So what you're doing in B is adding heat. The equilibrium is E plus F is the equilibrium with G, H, and heat. And guess what? I'm going to share the fun. It's your turn to try this. Again, you're trying to figure out what happens to the concentration of E and G. And you got two types of answers. One, it either increases, or two, it decreases. It will never on my test or any problem I've ever seen stay the same if you make a change, which we are. And anybody getting a headache from this, feel free after class to take your favorite painkiller. Oh, that was cruel. I'm sorry. And when you're done, give me a thumbs up. Thank you, Gianna W. And we'll be patient and wait for everybody else to finish. Thank you, Anna. Thank you, Jasmine. And thank you, Gianna J. So it's my turn to have fun. Now, when you put the reaction in hot water, what happens? Well, you add heat. At equilibrium, there was a certain amount of heat. By adding hot water, you've increased the heat. And now it has too much heat and says, oh no, I'm under stress. I have too much heat. I got to get rid of it. How do I do that? Well, the equilibrium will shift to this direction because G plus H plus heat will make more F and E, or E and F. So if we're shifting it in this direction, G is going to be consumed. When something is consumed, remember my cookie, the amount you have will decrease. And you could put an arrow down, or you could also write now, since you're getting rid of the excess heat, because you put it in boiling water or hot water, when G and H react with the heat to shift the equilibrium this way to get rid of the excess heat, you make more E and F. Well, if you make more of something, the amount you have, in the case of E or F, will increase. You do an arrow up, or you could also write goes up. And that's how you do it. Remember, ice bath removes heat, boiling water, hot water adds heat. Now, this is for an exothermic reaction where the heat is on the right side, on the product side. Let's look at an endothermic reaction. All right, everybody see on the screen, endothermic reaction. Thank you, Giannos. All right, how do we know it's endothermic? Heat is on the left side, the starting material or reactant side. So what this tells us is heat reacts with E and F to make G and H, and G and H will react to make heat E and F, and that's an equilibrium. All right, what happens to the concentration of F and H if I put the reaction in boiling water? Well, what stress are you doing to the reaction, the equilibrium, when you put it in boiling water? And the answer is boiling water adds heat. So at equilibrium, there was a certain amount of heat, E, F, G, and H. Now, by putting it in boiling water, oh no, there's too much heat. I've got to get rid of all this extra heat. What do I do? Well, the only way you can get rid of the excess heat is to react with E and F, which means you shift the equilibrium this way. Heat, E, and F react to make more G and H. So if I'm shifting it to the right, making more G and H, F is consumed, that reacts. And because it's consumed, the amount will decrease. Just like if you eat half a cookie in the big cookie in your hand, how much will you have? Less, the amount decreases. Goes down with an arrow or goes down inwards. Now, what happens to the concentration of H? Well, you put in excess heat, it reacts with E and F to make more G and H. That's why it's shifting this way to get rid of the excess heat. Well, if you make more of something, the amount you have will increase. Goes up. I guess you could also write down gets larger. That would work for me too on a test. Did I tell you I'm this close to the person who grades quizzes and tests? Me. All right, let's do another one. I'm going to let you have the fun of doing it. All right, your turn. 4 points. What happens to the concentration of E and F in this equilibrium reaction if you put the reaction in an ice bath? And let me just remind you, ice bath removes heat. Again, ice bath removes heat. And it's your turn to have some fun. I hope you're all having fun with the Chattelier's principle. In today's lab, you'll have a lot of fun. It looks really like a lot of fun. And I'd like to thank all my regulars for coming to lecture today. Just think about it. You didn't have to drive in the bad weather. Speaking of that, I can go cheat for a second. Not cheat. If you look at the traffic map, I don't know if you can see it or not. This is not the traffic map. See all those red dots? Those are accidents. Let's see if I. Oops. And that's picture at 3:55, which looks pretty crowded. Aren't you glad you're not out in that bad weather? I am. And give me a thumbs up when you're done. Remember, ice bath removes heat. Thank you, Anna and Jasmine. Thank you, Gianna. Jay. And we'll wait. Thank you, Gianna Williams. We don't have to wait. So let's take a look at this. What happens to the concentration of F and H if you put it in an ice bath? Well, at equilibrium, there's a certain amount of heat, certain amount of E, certain amount of F, certain amount of G and H. Well, when you put it in the ice bath, the amount of heat is reduced down. And it says, oh no, I don't have enough heat. I need to make more heat. And how can it make more heat? G and H react to make more heat. When they make more heat, E and F are also made. Now, since it's shifting to the left, the equilibrium, to replace the heat, G and H are consumed. And if something is consumed, G and H react to make more heat. When they react, H is consumed and the amount of H will decrease. Now, if we look at F, at equilibrium, there was a certain amount of F. In order to make more heat, G and H react, and they make more heat, but they also make more E and F. And since you're making more F, when you make more of something, what happens to the amount you have? It increases. It will increase. It goes up, and that would be the answer. Now, let me clarify something, because sometimes students get confused. If I were to ask this question on a quiz or a test, you could either write increase, you could also only write arrow up, or you only have to write goes up. You don't have to write all three of these. Any one of these would be a correct answer, so you don't have to write all three. Now, if I look at the clock with today's lab, today, right now would be a good time to take a 5-minute break, come back in 5 minutes by my clock, this computer clock would be 9:51. I'm gonna get up and stretch and look out my weather window, my front living room window, see what the snow is doing. See you in 5. Time to get going. All right, guess what time it is? It's lab time. And today's lab, let's take a look at it. Deals with equilibrium and Le Chatelier's principle, which we just talked about. Now, if you notice here, one of the solutions you'll be working with is 0.1 molar, capital M, silver nitrate. Can everybody see the little brown bottle on the screen? Thank you. Listen carefully. Silver nitrate is not hazardous, but if you get it on your skin, it will turn your skin black. When I talk about black, I mean this color black. No matter what pigment you have, it will be this color black. By the way, this is one of these I use for my hobby. I have a whole set of them. Or this color black, or this color black. And the bad thing is, it won't wash off. You've got to wait until the skin wears off. When I was in high school, our chemistry instructor, my first one in sophomore year, didn't warn us about silver nitrate. And for about 8-10 weeks, I had a bunch on my hands because I wasn't wearing gloves. We didn't back then. Had freckles on my fingers, black spots that finally wore off when the skin wore off. So today's lab, it's really important. Wear gloves. Also, I'd wear a long sleeve top just to be careful. And when you're done with the lab, before you take your gloves off, I would wash them under water. Get any if you have any silver nitrate. Also, I would be careful wherever you're doing it, and I'd put some saran wrap, plastic wrap on the countertop just so you don't spill any on there. And you, later on, somebody like you or someone else, if you didn't clean up after, which you should, touches it, goes like this, you're going to walk around with a black spot. You don't see it initially, but once you get outside in the sunlight, even if it's an overcast day like today, the reaction oxidizes your skin black, and you can't wash it off. You have to wait until the skin wears off. So be careful with the silver nitrate. We've used it many times when I did this lab face-to-face or similar. We've used silver nitrate, and I just warn students, when you're wearing gloves with this lab, don't scratch your ear, don't scratch your cheek, or go like this with your gloves on, because you might spend the next 8 to 10 weeks with black spots wherever you touched it. So you've been warned. Again, it's not dangerous. It's just you want to go around with black spots. All right, as always, you should wear goggles. You should wear your gloves. Now, you don't need an apron. Oh, you should. It's always good. But I would definitely wear a long sleeve top so your skin's protected in case you splash. You won't get it directly on your skin, and you won't have black spots. When I mean black, I mean black. Now, here they talk about equilibrium, and we've already covered this, talking about the forward and reverse rates are the same. And here they talk about exothermic and endothermic reactions. Now, everybody see here where they have N2O4 and the G is for gas. You can ignore that. Is in equilibrium with 2NO2 nitric oxide. And then they have plus 57.2 K capital J. Everybody see that? Thank you, Jasmine. What that 57.2 K capital J, that's kilojoules, and that's a measure of heat. And what they're really saying is N2O2 is in equilibrium with 2NO2 plus heat. And later on, they show the Haber-Bosch reaction, where instead of using a number, they use heat. Now, today's equilibrium will be this one. They show the stepwise, but the important thing is this one right here. And here, you'll take copper chloride solution, see where it has here copper 2 chloride, 0.5 capital M solution. That's going to be the key reaction. And notice before you add anything, it's just in water, it's that nice blue color, which means once you add it to water, it forms this copper hexahydrate, which is blue. And the equilibrium you'll be investigating is this right here. I like writing +2 instead of 2 plus, so I will. Now, the copper hexahydrate is blue. Now, hopefully none of you are colorblind. If you are, I'm being serious now, let me know and I'll help you out. When I worked in industry at one company, two companies, each one, I had a chemist who was colorblind, red, green. In certain tests, someone else would have to help that chemist out because the chemist couldn't see blue, uh, red, blue, I think it was. And we helped them out. But anyways, and her at another company. All right, so here's the equilibrium. What you're going to be doing is first testing is what I'm telling you the truth. And how are you going to do that? By adding and removing Cl minus. How can you add Cl minus? Sodium chloride, remember that's Na plus, and Cl minus, when you add this, when you add sodium chloride solution to the copper hexahydrate, you're going to increase the amount of Cl minus. And that should shift it to the right and make it go from blue to green. Now, the nice thing about chemistry and science in general is, am I telling you the truth? Good question. Thank you. And you go in the lab and prove it. And that's what you're going to do today. You're going to add sodium chloride and it should go green. If it doesn't, and depending how much, how green it gets, it'll be less blue, more green, the more you add. Now, the other thing you'll be doing is adding silver nitrate. And what does this do? Silver nitrate reduces the chloride anion level. How does that do that? This will be in solution as silver ions and chloride. I think this is a +2. Let me look something up. Even once in a while, Dr. White has to look stuff up. Nope, it's a +1. I was right originally. I wasn't sure. And the reason you're adding silver nitrate is the silver ions react with the chloride ions to make silver chloride. And this is a solid, which means it precipitates out. And by doing that, when you add the silver nitrate solution, you reduce the chloride ion. And if that's true, when you add the silver nitrate solution, it should go shifting this way because you've removed some of the chloride to replace it. The copper chloride green reacts with water to make more of the blue copper hexachloride and more of the chloride. So when you add this salt, it should go green. When you add the silver nitrate, it should go blue or bluish. So that's the first part of what you're going to do. I'm going to go through the lab in a second. Now, part of today's lab is to determine is to determine if this reaction is exothermic, that means the heat's on the right of the equilibrium, or exothermic, the heat is on the left. And how are you going to do this? Well, you're going to have the reaction and you're going to put it in a beaker of ice water and you're going to put it in a beaker of warm water, not boiling water, warm water. And you can get the hot water from your kitchen tap in a beaker, and then you'll put the test tube in there and you'll look at the color. Now, let me teach you something about how to determine this. In today's reaction, you're going to find out, is heat like in reaction 1 or is it like reaction 2? In 1, it's exothermic. In 2, it's endothermic. Now, remember, an ice bath, ice and water, ice cubes and water will remove heat. And hot water adds heat. So what does that mean? If when you put it in an ice bath, it will shift the equilibrium whether it's 1 or 2, when you put it in an ice bath, you're removing heat, so the equilibrium shifts to the equilibrium, to the side with heat. It doesn't matter if it's exothermic or endothermic. And with hot bath, hot water, since you're adding heat, it will shift the equilibrium will shift it to the side without heat. And today's lab, you'll determine which way it shifts in an ice bath and hot water by the color. Remember, ice bath shifts the equilibrium to the side with heat. For hot water, it shifts the equilibrium to the side, and this is important, without heat. And that's what you're going to be doing. Now, the original reaction up here, either heat's on this side or it's on this side. And that's what you're going to have to determine. How do you do that? Well, let's take a look. Now you need all this equipment. Remember, wear your gloves. And you'll need some sodium chloride. Hopefully you have kosher salt. Why? Well, I don't think it'll really matter here. It really won't, but it's better. Kosher salt is pure sodium chloride. If you have iodized salt to help with your health when you're young, that's why they put it into salt for young kids. I forgot what medical remedy it helps, but they also put in sodium iodide, NaI. But kosher salt is pure NaCl. Please pass the nickel. And if you can, get bottled water for this. If not, it still should work, but it's better to have bottled water. Now, if you notice here in safety, they have copper chloride and silver nitrate can cause skin and eye irritation. Wear your goggles, wear your gloves. Notice copper chloride can be corrosive to metal surfaces. So that's why I said put some saran wrap, plastic wrap down underneath where you're doing this today, or whenever you do it. As you notice, you should always wash your hands afterward and clean up with soap and water. But what they don't tell you is it will turn your skin black. Well, I don't know why they don't. All right, now there's certain procedures. You have to make up the sodium chloride solution, put 15 milliliters of water in a weigh boat, weigh out 4.5 grams of sodium chloride, put it in your graduated cylinder. I have a weigh boat. Remember I showed you last time, the weigh boat, you pick up by the corners and that folds this way and you can dump it right into the Erlenmeyer flask. And then you'll swirl it till it dissolves. Now they say put it in the microwave. If you swirl it good enough for a while, you don't have to, but maybe you do. If you do put it in there, be careful, it can be hot. Now, you're going to need to take 5 of your test tubes, and each of those put about 2 milliliters, 40 drops, give or take a couple. You don't have to be exact for this lab. And test tube 1 will be the control, what it looks like when you have the copper chloride or copper hexahydrate, blue. And using a 10 ml cylinder, you'll put 1 milliliter of your salt solution to test tube 2, swirl it, and look at that. Now, they give you a stir, but what do I have? Let's assume this is a giant test tube, really one of your smaller ones. Hold it in one hand, take your finger, go 1, 2, 3, 4, 5, and that will mix it up pretty good. Don't tickle it, it won't mix. You really got to hit it hard, but hold it firmly so it doesn't go flying. Now, I think they have a stir in there. Let's take a look. Nope, they don't. In the lab at COD, we have them. But remember, hit it like that a couple of times, 4 or 5, don't tickle it, and that will stir it. Now, in activity 2, you'll add 1 milliliter of the silver nitrate solution, about 20 drops, 25 drops. And, oh wait, it's in a bottle without an eyedropper. Let's take a look. Yep, it is. So use your eyedropper and look on that and add about 2/3 of the eyedropper. And then what you'll do, mix it, let it sit for 5 minutes, and look at what color it is. Now, you don't have to take photos for this lab unless you want to. I like seeing them, but I'm not giving any extra credit points. And then activity 3, you'll add water to test tube 4. And mix it and let it sit for a while and determine what happens to the color. Now, they also ask you to add it to compare test tube 4 to solution in test tube 5. And you add 3 milliliters of water to test tube 5. And then for activity 4, you'll take hot tap water and you can measure it with your thermometer. Mine's pretty hot where I keep my hot water heater back this year. I had to buy a new one. If anybody needs good plumbers, I found this really great plumbing company. They've done a number of things in my area. And in fact, I found out about a year and a half ago when the village came out for something, when they had to fix something in the sewer line, their stuff. I told them about, well, I'm using this company. And said, yeah, we do too on occasion. So my village, Schaumburg, uses this company and is very happy with it. That's what the gentleman who were doing the work from the village said, they're good. Now, here, what you'll do is fill your plastic cup, fill the beaker with water, and then a plastic cup, you'll put it half full of ice cubes and then add regular tap water, and that's going to be cold. And then what you'll do is put the test tube 4, 5, and 4, compare it, and then you'll put 1 in the hot water and 5, and you'll let it sit for a while and look at the color, and then compare it, and then you'll do the other. Where you put it in the hot water, I missed it. Number 5 in the hot water, and then put it in the cold water. And it'll go back and forth because you're adding and removing heat. Now, here's where all you have to do is, on this table, record the color of the solution for each one. Test tube 1 should be blue or you're doing something wrong. And then when you have the hot water bath and the cold, you look at the color, and when you put it in there, record the temperature and then the solution. Now, you don't have to record the solution temperature, just the water bath temperature will be all right, and the color. And that's today's lab. Now, let's look at the write-up, and I'm going to have to open it up first. I was just looking at something real quick. All right. You should fill out this table 1 and 2, and then answer questions 1 through 6. You don't have to answer 7 or 8, and you don't have to do the photos unless you want to. I'll enjoy looking at them, but you only have to do questions 1 through 6, and I'll put that in the lab on Blackboard because I'd looked at it last night, but I didn't have time to do it. So remember, when you're working with silver nitrate, wear gloves. Don't touch your nose, your face, or anything else when you have your gloves on working with silver nitrate, or your skin will turn this color black or this color black, and it'll take at least 8 or 10 weeks before your skin wears off. So if you don't want any unsightly black freckles or spots, be careful. Before you take off your gloves for today's lab, use your elbow, turn on your I'll answer Gianna's question in a second. Before you take off your gloves, wash it under water to get the silver nitrate if you do. After you take off your gloves, I'd wash my hands again. All right, now, Gianna asked the question, we don't need the solution temperature for the second table? And the answer is yes, you do not. If you know the ice water and the hot water, let it sit there for about 5 minutes. That's fine. When we actually do it in the lab face to face, we don't measure that temperature because we use hot water. That we do in the ice bath. I have my students, but don't put it in this. It's going to get cold. Trust me, I'm a doctor. Did that work? How about trust me, I'm an organic chemist? Did that work? How about trust me, I'm a PhD organic chemist, a doctor and an organic chemist? Well, with that, I'm done for today. Remember, if you ever have any questions about anything in my course, always feel free to ask. As I said a number of times, and I'll say it again, there's no such thing as a dumb question in my class or in my universe, my life. Therefore, anything related to Chem 1211 or other things too. I don't know about the other things, but 1211, I can answer any question I'll bet you ask. Ask. Today I'll have my office hour from 6 to 7:15 on Zoom. Same thing tomorrow night. So if you have questions about the lab or anything else, stop by, say hello. And with that, I'm going to say, Gehen gesund, go in health. That's what that means in Yiddish. And I'll say, bye now, Gehen gesund. I stole that from Granny of the Beverly Hillbillies. Bye.